All right, confession time. When I was a kid in the 80s, fanny packs were a big thing, and I didn't know any better, and I wanted one. And I wanted a Ninja Turtle fanny pack, but never got it. And I'm okay with that. I'm really okay with that. I don't need one now. So your favorite store, Forever 85, you plan to purchase several fanny packs, okay? You have a coupon for $10 off and a coupon for a 25% discount. We're gonna write a function f. Let's just stop right there and write a function f that represents the price you would pay on an item that originally cost X dollars after taking the $10 discount. So, okay, here's the deal. You walk up to the counter and you say, I have $100 worth of fanny packs, but here's a $10 off coupon. They would say, oh, that's 90 bucks, right? Because you're just gonna, let's be real honest, subtract 10 from how much it costs. That one was easy. Now we also have another function that's g. It's the price you'd pay that originally cost X dollars, but we're going to take a 25% discount. And you might say, okay, well, X minus 25. No. That'd be $25 off. And you might say, okay, well, 25 times X. That would be 25 times the amount you would normally pay. All right, let's not play that game. And then you might say it's 0.25 because it's a percent. Okay, I hear you. 0.25 times how much you would pay. All right, we'll try that. Let's suppose you're going to buy $100 worth of fanny packs. Okay, 0.25 times 100 means you're going to pay $25, right? I mean, you didn't have to type that, but you had a visual for it now, right? You got a visual. So you're going to pay $25 when you have a 25% off, a 25% discount. So if it's a 25% discount, you're not going to pay 25%. You are going to pay 75%, put the decimal in the appropriate place. There we go. So if I bought $100 worth of fanny packs and played this coupon like it's like a playing card, playing Uno, if I'll lay down this card, I would pay 75% of it. Okay, you make a total purchase of 20 bucks and you want to use both coupons. Is it to your benefit to represent one coupon before the other when checking out? If so, which coupon should be presented first? Oh, okay. So I want to buy 20 bucks worth of fanny packs, and I want to know when I'm standing at the counter, do I say, oh, I have this coupon and I have this one? Or should I say I have this one and I have this one? Okay, here's what I'm saying. Is it better for me to say, let's apply the G coupon first and then F, working our way from the inside out? Or is it to my advantage to apply the F coupon first and then G? Let's figure it out. Okay. F of G of 20, well, that means the F hangs around. 20 goes right there. 20 times 0.75, 75% of 20 is 15. This gives me 15 minus 10, that's 5. Okay, I just paid $5 for $20 worth of fanny packs. Lucky me. Wow. Okay, now we'll try it the other way. I have G of, let's see, F of 20. 20 goes here. That gives me a 10. And now we're going to plug a 10 in right here, and 75% of 10, 25% off, would give me $7.50. So it is to my advantage to do it this way. So here's what I'm going to write. I'm going to write it in red. We'll put it in the middle. I should present the 25% discount first, then the $10 off discount, coupon, whatever you want to call it. That is going to give me a lower final price. Let's keep going. You make a total purchase of 50 and you want to use both coupons. It's the same idea, just a different number. So let's do the same thing. Going to go a little faster now. Oops, 50. And we'll do G of F of 50. 50 is going to go into the G function. All right, so 75% of 50, in case you never knew that, a fourth of 50 would be 12.5. If you take, whoops, lights went out. If you take a fourth of 50, you get 12.5. Subtract that 12.5 from 50, you have $37.50. And then $10 off of that would be $27.50. Okay, if we do this one first, we'd have, let's see, G of, that'd be 40, because we would subtract 10 from 50, and then we'll take 75% off of that, and that would be 30. Okay, so this one's more, second one's more. And so it's the same idea, and I'm not going to waste my time writing the same answer again, so same thing. Okay, so we're going to write and simplify both of those functions, and then I want to see if it's consistently better to use one coupon before the other. So as I shop at this, does the amount determine which coupon I should lay down first, or is it always going to be what I've seen consistently so far? Okay, so if I buy $1,000 worth of coupons, does that somehow tip it into some territory where this is more beneficial? That's what I'm really asking. So let's write and simplify the functions f of g of x and g of f of x. And we'll just do that, and then we'll answer the rest of the questions. So f of, okay, well, g of x is 0.75x. Okay, so I would say, well, let's plug an x in. Well, there's no x to plug. I mean, it's what it is, all right? That's g of x, so just write it. Now, this becomes my input. This is now my input. As I look at this, I say, okay, well, this is going to go in the place of x. So 0.75x minus 10. So 0.75x minus 10. Okay, that one's simplified as far as I can go. Let's do this one. All right, well, f of x is x minus 10. Okay, so now we're going to take this x minus 10, and it is my input. And so x minus 10 goes right there in the place of x. So 0.75 x minus 10, and we'll just keep simplifying. So 0.75x, and then 0.75 times 10, that is 75% of 10, that would be 750. There we go. All right, so here's the deal. Is it to my advantage to always consistently use one coupon over the other one, which so far it looks like it'd be the FG order, which would actually be G first, F of G of whatever. Or do I reach a point where it's to my advantage to use the other one? So if I were to graph both of these, they are linear and they have the same slope. There's a graph in my head that I want you to see. Okay? The graph in my head has a slope of 0.75, that's 3/4, on both of them. 1, 2, 3, 4, 5, 6, 7, and I have 8, 9, 10. And so this graph, we'll do it in blue. This graph's going to go up 3/4. It's going to be something like this. Okay, so this right here is 0.75x minus 10. This is f of g of x. And then this graph is going to be the other one. It's going to be down 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7.5. And then up 3/4. It doesn't have to be perfect, but it's going to be like this. And this graph right here is g of f. Whoops, g of f. Let's get the white out. G of f of x, which is 0.75x minus 750. And so, which one is lower? These are the prices I'm paying. Now we're going to reach a territory like down here where they're giving me money, which is not realistic, but eventually we get above the x-axis on this, on these. And so one of them is consistently lower than the other one, and that one that's lower is this. So here goes. It is always to my advantage, and I'm going to get a little more specific. It's always $2.50 cheaper to do, I'm going to word it differently, G first, then F. Notice that that's 250 more than that. That's 250 more than that. And this, minus 10 and minus 750, this is 250 more than that. And you can see with the parallelicity of the line.